Hello everyone and welcome to today's class. So we are today going to continue with the question answers that we were doing from the P block element chapter. We were mainly doing from group 16 and 17 question. Today we will start with group 17 question from one of the group 17 question, and probably we will end our discussion from this particular chapter today. Probably the question is that how will you explain that XCF4 has a square planar structure? Now, we are going to do the hybridization like the previous molecular structural question that we had done. Molecular structure based explain on the basis of hybridization concept. That's why we are going to take the help of that concept. Now, xenon Xe is fifth period element. Electronic configuration, we know that 5s, 5p, 5d. Now, ground state electronic configuration of xenon is 5s2, 5p6, and 5d is vacant. So, this is the electronic configuration of xenon in ground state. Now, XCF4 have 4 sigma bond with between the xenon and fluorine. So, xenon, the central atom, required 4 unpaired electron. So, xenon will have an excited state. Xe in XEF4. One pair electron from the 5p will jump to the 5d electron and thus will create 4 unpaired electron, and 4 electron from 4 fluorine atom will be shared, and as a result of this sharing, 4 sigma bond between the xenon and fluorine atom is formed. So the hybridization becomes sp3d2. Now the shape of sp3d2, a hybridized molecule, is usually octahedral, but in this case xenon contains 2 lone pair of electron. So as a result, the structure will be Xc 4 fluorine atom on the square planar plane, and the 2 lone pair will be perpendicular with the square planar plane. We know the name of the structure is square planar. The next question is again a molecular structural based question. The question is saying that how will you explain that XeO3 has a pyramidal geometry? Now, again, we are going to take the help of hybridization, but let's see first the structure of XeO3. Now, the normal structure of XeO3 is this one, where xenon, the central atom, contain 1 lone pair of electron and 3 oxygen atom is bonded with the central atom xenon with double bond. Now, the double bond, the 3 oxygen atom form 3 sigma bond, so and 3 pi bonds. Total 6 bond with 3 oxygen atoms. So 6 unpaired electron is required in the central atom xenon to create 3 sigma bond and 3 pi bond in total. So let's see the valential electronic configuration for xenon. The valential electronic configuration of xenon is 5s, 5p, 5d. The ground state electronic configuration is xenon is 5s2, 5p6, and 5d0. Now 6 unpaired electron is required in the excited. So the xenon in XCO3 will have the excited state in which 3 electron from 5p orbital jump to the 5d orbital, thus create 6 unpaired electron. An oxygen atom, thus by sharing electron, each oxygen sharing one electron produces 3 sigma bond, and thus the hybridization becomes sp3. Now the 3 electron in the d orbital are shared with oxygen to produce the pi bonds. They are not included in the hybridization concept. The hybridization concept only consider the sigma bond formation. Thus, the bond that we will get, the actual shape of sp3 orbital should be tetrahedral, but as xenon, the central contain one lone pair of electron, the shape of the molecule become xe o double bond and a lone pair of electron over the xenon, making the pyramidal shape. XeO4 is another um, XeO4 is another molecule of xenon. It cannot be stored in glass bottle. Why? Now, glass is nothing but SiO2. Glass is nothing but SiO2. XeOF, if stored in a glass bottle, it reacts with SiO2 to produce XeO2F2 and SiF4. As XeOF4 reacts with SiO2, reacts with glass, it cannot be stored in glass bottle.